Hi there, good morning, good afternoon, good evening. In this lesson, I think I will be able to just explain briefly on binomial expansion tutorial sheet. I think I'll break it into two parts. Maybe in this video, I'll be able to explain the first concept of maybe question 1. If maybe time allows, I can also touch question 2. And then we'll continue and so forth. So the first part, I'm sure the binomial expansion, I think we sent you some notes on what binomial expansion is and the like. So with the understanding which you did in the notes of binomial expansion, I want you to try to see if you're able to practice one or two things from this tutorial sheet 8 for binomial expansion. So there is a question there which says that, okay, what do we have here? Pen, color. Okay, so there's a question there. Remember, this is still source tutorials. And you can reach us on 0964 736805. So what we have, we are being told that express the following in factorial notation. So the concept here is understanding the meaning of factorial notation. What is factorial notation? The factorial notation, if you have to understand here, is a situation whereby when we have any natural number n, so the factorial of any natural number n, which is denoted by this, is simply a product starting from the n itself multiplied by the decreasing of n. So we're going to have n multiplied by n minus 1, it means n has decreased by 1, multiplied by again n minus 2, it means n has decreased by 2, multiplied by n minus 3, n has decreased by 3, and the product will still continue until we reach a point where we are going to have 1 multiplied by 1. So it's just a decrease in product, until we reach a 1. So n factorial is that n is representing any natural number which can be taken as n factorial. So remember, this factorial denotation is only defined for positive values. Negative factorial does not exist in most cases. But now we'll look at certain situations where we can be able to find the combination of a certain negative value combination, positive value. But remember, the negative factorial of a number is not quite right defined. So that is why a factorial notation will only talk about is for positive values of n. So n factorial will be product of the next values which are smaller than n. That's what we're talking about. So for example, if I had e.g., let's say I'm talking about 9 factorial. 9 factorial will become just as good as 9 times the next digit will be 9 minus 1, which is 8, multiplied by the next digit will be 9 minus 2, which is 7, multiplied by the next digit, which will be 9 minus 3, which will be 6. So the decrease will continue to be 5, 4, 3, 2, until we reach a 1. That's why we stop. So n factorial will just be a product of those until you punch in the multiplication and so forth, so that you can have a certain value and so forth. So in a situation whereby I have maybe 4 factorial becomes 4 multiplied by 3 multiplied by 2 multiplied by 1 and so forth. So the rules of factorial notation is that 1 factorial by default is always equal to 1, and at the same time 0 factorial will also be equal to 1, and the negative number factorial does not exist. That's the rule of factorial notations. So here we want to write all these expressions in terms of factorial notation. So the concept we are going to use here is the combination concept. So we'll use the factorial concept, at the same time we'll use the concept of combination. So we'll use the concept for combination, where we are simply saying that n combination R which can be written like this, or which can be written as NCR. So these two are just the same notation. They are simply representing combinations. I'm sure I explained last time to say a combination is just the number of ways we can choose R values from the N values. So those are the combinations we're talking about. So the combination, if I say NR, N combination R, the formula which we're going to have is just as good as N factorial divided by N minus R factorial multiplied by R factorial. So this is the formula we are going to be using for combination. So if you look at those fractions given there, obviously we are looking at it in a situation where we can be able to use such a representation. When we have such a representation, obviously we are able to embrace it and we'll be able to use it. So N factorial, we know that it is a decrease. N minus R factorial, we have whatsoever values we have, and then R factorial, we know what factorial symbolizes. So number, we are coming to a situation where we want to solve the first question there. So the first question is, can you write this in factorial notation? So we want to write 7, is it 7? Let me just confirm. 7 by 6 by 3 by 2 by 1. 7 by 6 by 3 by 2 by 1. 7 by 6 by 3 by 2 by 1 divided by 2. We want to write this in factorial notation. Now we know what factorial notation is, a product of its decreasing factors. Now if you look at this, you have to be very strategic here. This is 7 by 6, yapela, and it's not continuing to 5, 4, 3, 2, and so forth. So there is a missing 5 and 4 for this to become a 7 factorial. So on top here we don't have a 7 factorial, but we know that we can write this as, if I was to keep the 7 by 6, this is not yet in factorial format, but 3 to 1, this is obviously a 3 factorial, multiplied by 3 factorial, because 3 times 2 times 1 is the same as 3 factorial, because 3 factorial here is 3 multiplied by the next value, which is 2, multiplied by the next value, which is 1. This is divided by what? 2. But if I want to take this as a factorial form, how can it be? Remember, 7 factorial, recall that 7 factorial is equal to 7 multiplied by 5 multiplied by 6, multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. But here we only have this part. It means the 5 factorial is not visible there. That's what we have to understand. So it means that this 5 factorial, for it to be replaced there, it cancelled out with another factorial to that. So for me to make this a 7 factorial, I will basically multiply both sides, the numerator and the denominator, by this missing 5 factorial. So it means this is just as good as 7 multiplied by 6 multiplied by 5 factorial for this to become a 7 factorial. But whatsoever I do down, I do on top, I also do it down. So even down I also include the 5 factorial, so that we don't change the meaning of this. So 5 factorial divided by 5 factorial, it can cancel out. Remember, we still continue. This is 3 factorial multiplied by that, and then punch up, we have a 2 factorial. 2 as it is the same as saying 2 factorial. So with this information, therefore, what am I going to have? I'm just going to have something like 7 times 6 times 5 factorial. Now it can be written as 7 factorial multiplied by 3 factorial over 5 factorial multiplied by 2 factorial, and you are done. The concept is write the expression in a factorial notation. So the factorial notation we have here is, we've broken down the 7 times 6 into the 7 factorial by introducing a 5 factorial on both the numerator and the denominator, so that it can be complete 7 factorial there. So from that concept, from that concept, what is happening? We are saying that the 7 by 6 by that will now be taken to be my screen now. Okay, so we're saying that with that denotion, we're simply saying that 7 by 6 by 3 by 2 by 1 over 2 is now written in factorial notation as 7 factorial multiplied by 3 factorial over 5 factorial multiplied by 2 factorial, and we're done. So that's the concept on how we'll be able to write the factorial notation. Okay, now let's look at the second part. I'm going to delete this so that we can now look at the second part. Let me delete this so that we can now look at the second part. So the second part says write the factorial notation. In factorial notation, we should have 49 multiplied by 35 divided by 2 multiplied by 1. So how do we write that in factorial notation? Okay, let me just delete this just to create some space in my workspace. Okay. So we have the second part B, which says we have 40 multiplied by 39 over 2 multiplied by 1. How can this be written? This is 49 times the next decreasing by 39. But for this to be 40 factorial, it was supposed to be multiplied by 38 factorial. So it means we introduce a 38 factorial in both the numerator and the denominator. So I'm going to have a 40 by 39 multiplied by a 38 factorial. The whatever I do on top I also do down. Multiply by 38 factorial. 2 by 1 is the same as the 2 factorial. So 40 to there, this is now the whole numerator here will now become a 40 factorial, because 40 factorial is 40 times 39 times 38 factorial over here we have 38 factorial multiplied by 2 factorial, and you are done in factorial notation. And you even understand that with this information here, 40 factorial over 38 factorial minus 2 factorial, this is just the same as saying 40 combination 2. If you look at it very well, this is just the same as saying 40 combination 2, because when you use the formula, combination formula, 40 combination 2, n is 40, r is 2. So it means you have n factorial, which is 40 factorial, n minus 2, which is 40 minus 2, which is 38 factorial, and 2 factorial. So just from this concept here, you can see that this is just a combination formula, and you are done. Then we can also talk about the third part. The thing is, the screen is responding slow today. So the third part is where we have n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 yapera divided by 3 multiplied by 2 multiplied by 1. So how do I represent this in factorial notation? We can see that here the n is decreasing product. N times n minus 1 times n minus 2 times n minus 3. The next one was supposed to be what? N minus 4. So what are we going to do? We are going to introduce an n minus 4 factorial on both sides so that we can have the n factorial on the numerator. So this is just as good as n multiplied by n minus 2, minus 1, n minus 2, n minus 3 multiplied by n minus 4 factorial. But since we've introduced an n minus 4 factorial, the same should happen in the denominator, n minus 4 factorial. And this 3 minus times 2 times 1 is the same as 3 factorial. So that what am I going to have? From n to there, this is just as good as n factorial over n minus 4 factorial multiplied by 3 factorial, and you are done. So that's what we have there, n minus 4 factorial and so forth. Then the next part we can show. Do we have the next part? Oh, this was the last part. So the next part we have is write this as well in notation format, factorial notation format, where we have n multiplied by n minus 1 multiplied by n minus 2. So how do we write this? This is just the numerator itself. So for me to write this in factorial notation, we introduce a denominator. So it means this is the same as saying n minus 1, n minus 2. It means it was supposed to continue to n minus 3. So we denote it by n minus 3 factorial, but we also write down n minus 3 factorial. So what does this mean? This means that from here to there, this is n factorial divided by n minus 3 factorial, and you are done. That's the concept we have there. So when that is done, then obviously we are good to go. So what we have here is indeed a representation of the factorial notation. Let's go to the B part now. So factorial notation, you just have to understand that it is a product of its decreasing term, just like that. So let's go to the second part, B. B says simplify the following. B says simplifying the following. So as you can see here, we said that all these brackets here represents my non-Canva combinations. So when we have all these brackets, this represents my what? My combinations. So if I have n r, this means it's the same as saying n combination r, which can be treated as n factorial over n minus r factorial multiplied by r factorial. That's what we have to know there. So it means that if I was to get a certain value, let's say for example I have 20 combination 2, this is 20 factorial divided by 20 minus 2 from the formula. This is 20, this is 20, r is 2. 20 minus 2 factorial and 2 factorial. So this will lead us to 20 factorial. Remember, I want to simplify this, so it means of simplifying back to the lowest terms. So 20 factorial is a product of 20 times z until we reach a 1. But 20 minus 2, this is 18 factorial. 2 factorial is obviously 2 factorial. 20 factorial, you can write it as 20 multiplied by 19 multiplied by 18 factorial. Remember, 18 will be product of 17 and so forth. So that I can even end at 18 factorial so that it can be easy for me to cancel out things. 18 factorial divided by 18 factorial, this can go. Because 20 factorial is a product of 20 times 19 times 18 times 17. So instead of reaching 1, you can just write 20 times 19 times 18 factorial, because I've seen an 18 factorial down there. So that this leads us to a 20 multiplied by a 19 divided by the 2 times 1. 2 in there is 1, 2 in there is 10. So it means 10 times 19, the simplified version of what I'm going to have here to be a 190. As good as that. So this formula here only works best when it comes to positive values of n. If n is positive, then this will work out. But if you see that n is negative, then the formula which you are going to have will be something else. So for a negative or a fractional n, then you would use the formula where we are saying n combination r, which will be equal to, so if the n is negative or if the n is a fraction, instead of using this approach, you use a new formula where we are saying it is n multiplied by n minus 1 multiplied by n minus 2 multiplied by, the multiplication will continue until you reach the point where it is n minus r plus 1. This is where you stop from. When the n is positive, you stop at 1 when it is factorial formattation. But when n is negative or when n is a fraction, we'll stop when we reach n minus r plus 1 divided by r factorial. This is how we are going to solve this combination. It's different from the formula when n is positive, but when n is negative or when n is a fraction, this is the formula we're going to use. So just as we have seen in our expression here, we have negative 2 here, this is the value of n. We have negative 5 here, this is the value of n. We have 1 over 2 here, this is the value of n. So it means this formula will not work for this 1, 2, 3. I need to work out with this one, which is the second one. That's what I'm going to use. So until I reach n minus r plus 1, that's where I will stop. So let's solve some questions using that formula. So we are trying to simplify the binomial expression where we're trying to simplify negative 2 combination 4, which can also be written as negative 2 combination 4. So n is negative here, so it means we would use this formula. So before you even start breaking it down, remember the formula is this one, which I've just stated here. So it means the first thing, identify what is your n. Your n is equal to negative 2. What is your r? Your r is equal to 4. So find the last term. The last term should be n minus r plus 1. So n minus r plus 1 will be negative 2 minus 4 plus 1, which is going to give me a what? Negative 2 minus 4, that's negative 6. Negative 6 plus 1, that will give me a what? A negative 5. So it means that when I'm doing the product of the numerator here, I'm going to end at negative 5. That's where I'm going to end from. So it means that when this is equal to that, we're talking about negative 2 multiplied by a decreasing factor. Remember, negative 2 minus 1, that's negative 3. Again, negative 3 minus 1, that's negative 4. Negative 4 minus 1, that's negative 5. I won't continue to decrease by 1 because the formula says end on n minus r plus 1, and n minus r plus 1 is negative 5. So I'll end here in the denominator at negative 5 divided by r factorial. R factorial is 4 factorial. It means I'm going to have 4 multiplied by 3 multiplied by 2 multiplied by 1. As good as that. So it means when you multiply the numerator, what am I going to have? This is just as good as it. Obviously, we can even simplify this further. When I simplify this further, I can even start dividing throughout. 4 in there is 1, 4 in there is 1. It means I'll have a negative 1 there. 3 in there is 1, 3 in there is 1. I'll have a negative 1 as well there. 2 in there is 1, 2 in there is 1. I'll have a negative 1 there. So it means that denominator has a 1, numerator will have negative 1 times negative 1, that's positive 1. Positive 1 times negative 1, negative 1. Negative 1 times negative 5, that's positive 5. And the answer obviously should be a 5, and you are done. So as long as the n is negative, this is the formula you have to remember. Now the formulas won't be given, you have to know them by heart. So this is the formula for the combination when n is a negative or a fraction. The same is happening when we're solving this question. Number 2. Number 2 says negative 5 combination 2. Negative 5 combination 2. Negative 5 combination 2, this is a negative power. So it means we're talking about negative 5 combination 2. Before we start doing anything, what is our n? Our n is a negative 5. What is our r? Our r is 2. Then we'll end where? We are looking for n minus r plus 1. So what is this value? This is negative 5 minus 2 plus 1, which is going to give me negative 5 minus 2, that's negative 7. Negative 7 plus 1, that's negative 6. We'll end at negative 6. So it means that per numerator here will start negative 5 minus 1, that's negative 6. I won't continue further, I'll just end at negative 6. There's nothing like again minus 1, I'll just end at negative 6. So divided by 2 factorial. 2 factorial is 2 times 1, and this is just as good as this times that. This is 30 divided by 2, and the answer should be 15, and you are done. As simple as that. The same is happening when we have okay. So the same is happening when we have, this is 4, when we have 1 over 2 combination 2. This can still be written as 1 over 2 combination 2. So what do we do? Number 1, what is your n? Your n is a fraction. You remember the same formula. Your r is equal to 2. So it means we are looking for n minus r plus 1, where we will end from in the numerator. So n minus 1 plus r, this is n is 1 over 2 minus r, which is a 2. The answer plus 1. So this is just as good as 1 over 2. When we do the summation, this is over 1, this is over 1. When you do your summation there, 1 over 2, we are going to have a negative 1 there. So 1 over 2 minus a 1, what am I going to have? One over 2 minus a 1, what are we going to have? This is just the same as negative 1 over 2. That's our solution. So it means when I'm combination this, it means we'll start n factorial will be 1 over 2 multiplied by the 1 over 2 will decrease by 1. So 1 over 2 minus 1, which is this one. So this is where we'll end from there. Divided by 2 factorial, which is 2 times 1. And this is going to be equal to 1 over 2 multiplied by negative 1 over 2. The answer divided by 2. This multiplied by that. What do we have? This is as good as negative 1 over 4 divided by a 2. Negative 1 over 4 divided by a 2. The answer becomes negative 1 over 8. And you are done. So that is how you'll be able to solve combinations involving negative n and a fraction of n there. I'm sure for these ones they are simple. I think I will give them as an exercise. So the exercise will be the exercise should be on this video. We're going to have, can you solve or simplify what is 20 combination 2 plus 20 combination 3. This one is very simple because these are positive n, so it means you still use the same the actual formula for positive values of n. You can also solve 10 combination 7 multiplied by 7 combination 3. This is just as good as finding the combination here, the answer, plus find the combination of that. So these are positive values of n. So it means you will use n combination r to just be equal to n factorial multiplied by n minus r factorial because n is positive, unlike when n is negative or n is a fraction. As simple as that. So that's how you'll be able to solve those two. So can you kindly please solve those two and submit in our inbox. Submit in our inbox. Maybe with this remaining few minutes, for me, I can solve this question where we can try to simplify n factorial squared minus 1 over n factorial plus 1. So how do we solve this one? How do we simplify this one? The question is simplify. How do I simplify this one? So simplifying this one is just as good as recording that this is a difference of two squares. So a difference of two squares, we know that a difference of two squares is in a situation where we have a squared minus 1, which can be treated as a plus 1, a minus 1. So if this is a difference of two squares, there is a minus here, and this is a square, and this is a square. So it means I can treat this as n factorial plus 1. The another one will be n factorial minus 1. But remember, we have a denominator which is n factorial plus 1. So this is multiplication. It means I'm seeing something similar in the denominator and the numerator, which can cancel out this one, and this one can go. So that the simplified version becomes n factorial minus 1. This is a simplified version because the question just said simplify. So we have n factorial minus 1 as our solution. As simple as that. So if that is the case, you have simplified your expression. You have simplified your expression. We are okay? So what else? Can I solve another one? Let me see. Do we have another one which I can solve? I think we can solve something. Yeah. The last one before I cut the video for the first part. And the screen is dark. Okay. So before I cut the video, we want to simplify. We want to simplify. We want to simplify so the simplifying there which we are going to have will be n plus 2. This is n plus 2, but this is factorial over n factorial minus 2n plus 1 factorial over n minus 1 factorial plus, sorry, this is n factorial over n minus 2 factorial. So how do I simplify this one? So simplifying this one, we can just take it first of all parts by parts, then we'll later on combine per last. So the first part we're going to simplify is this guy. And then we'll simplify this one, we'll simplify that one, so that by the end of the night, we can just combine the two. So if we simplify the first term, term 1, how am I going to simplify term 1? I am going to have n plus 2 factorial over n factorial. This is just as good as this factorial means decreasing. So it means I'm going to have n plus 2, which is the first, multiplied by minus 1. This will be n plus 1. So if this decreases by 1, it means that we are going to subtract this minus 1 to be 2 minus 1. It means I'm going to have an n plus 1. Multiplied by, again, minus 1, we're just going to end up having an n, isn't it? So we're going to have n plus 1 minus 1, we're going to have an n. So that when you continue decreasing, it will be n minus 1. It means the next part I'm going to have will be n minus 1. But since I am seeing an n factorial here, I can end at n, but just add the factorial to show that this multiplication will continue mpaka pa 1. So n plus 2 factorial means n plus 2 multiplied by n plus 1 multiplied by n factorial, because this is a decreasing product. N plus 2 multiplied by its decreasing minus 1, that's n plus 1. Its decreasing minus 1, that's n. Its decreasing, that will be n minus 1. But since we will not go further because I'm seeing an n factorial down there, so that if I end at n factorial, this will be divided by n factorial, and this n factorial and this n factorial can go. So it means that the first term can be simplified from, when we multiply this, I'm going to have n squared. Just expand this, n squared, this times that, we're going to have n squared plus 3n plus 2 when we expand these two. So just simplify and expand this, you are going to have n squared plus 3n plus 2. That's the first term. The second term, term number 2, which is this part, we also do the same. What am I going to have? I have the part which I'm going to be 2 open brackets n plus 1 factorial divided by n minus 1 factorial. So how do I simplify that one? So what is going to happen here will just be multiplying everything by its decreasing term. So I have 2n plus 1 factorial. So this is now going to lead me towards 2n plus 1 factorial. So it means that the first term will be 2 multiplied by n plus 1. Then since it's factorial, we're going to, this n plus 1 would decrease by 1, isn't it? So it means it's n plus 1 multiplied by minus 1, that will be just at n. N again minus 1, we're going to reach at n minus 1. But since I'm seeing an n minus 1 down, I'll end there and I just add in factorial there. So what am I going to have? We have the numerator, which is 2 times n plus 1 factorial. Since the factorial is just for n plus 1, the n plus 1 is the one which is multiplying as a decrease. The n plus 1 is just the one which is multiplying as a decrease. I don't know what has happened to my screen. Let me just delete some things here. Let me just delete some things. I don't know what happened to my screen. Okay, let me just write nicely. Okay, so we have that 2n plus 1 factorial can be treated as 2 multiplied by, this is factorial, so it means we'll start from n plus 1 multiplied by a decrease by 1, that would be n, since n1 minus 1 is 0, so we just remains an n. A decrease again by 1, it will be n minus 1, it will be n minus 1. But since I'm seeing an n minus 1 in the denominator, I'll end there, n minus 1 factorial. Once again, it will be n minus 1 factorial, so that this and this can cancel out. It means that for the second term, what am I going to have when I multiply this throughout? N times n, that's n squared, n times that, that's n, multiplied by these two outside. This will just be as good as a2n squared plus 2n, since both the n and the 2 can multiply inside there. So this is the second term expression I'm going to have. So the first term expression is this one when simplified. The second term expression is this one when simplified. Now what is the third term expression? The third term expression was n factorial minus n minus 2 factorial. So what does this? N factorial, you know that this is just as good as n times n minus 1 times n minus 2. Since there's an n minus 2, we'll end there and write n factorial minus then factorial n minus 2 factorial. This and this can go. Then we'll have n times n. This is n squared. N times that, this is minus n. Then lastly, let's combine all the three terms now. Remember the combination. It was the combination was n plus 2 factorial over n factorial minus 2 n plus 1 factorial over n minus 1 factorial, then plus n factorial over n minus 2 factorial. This was what we had, which we were trying to simplify. So we've simplified each term. Now we'll just replace the simplified solutions of what we have. We'll just replace the simplified solutions of what we have of the first term, second term, and the third term. Then we combine. So the first term we had is, this is now going to be equal to n squared plus 3n plus 2 minus the second term which we had was 2n squared plus 2n, and the last term which we had was plus n squared minus n. So that when you simplify everything, this becomes n squared plus 3n plus 2 minus 2n squared minus 2n plus n squared minus n. Like terms together, n squared plus n squared, that's 2n squared. Our screen. Okay, I'm back. Not again. Okay, let's see. apologies for that. Apologies. I've lost my board. So we're now talking about combination there. So after combining, we'll have something like that, so that when we group the like terms, what are we going to have? We're now going to have n squared plus this n squared, which will give us a 2n squared, but there is minus this 2n squared there. Then we have, this is 3n minus 2n, this is an n, and 3n minus this 2n, this will give us a positive n, but there is another minus n there. And then what do we have? We have another constant value there, which is positive 2. I think this is the grouping of like terms which we are going to have. So n squared, this goes, we have that, this one and this one goes, and then we have minus that, then we have that. So that this becomes 2n squared, this is a 0, this is a 0, and the total answer should give us a 2. So the simplified version there, when you combine all the three, the answer should be equal to a 2, and you are done. That was the first part of this question 1. We are okay? That was the first part. And then you can, I think, let me cut this video here, and then we'll continue in the next lesson. So we've solved question number 1A and B for this video. Question 1A and B. We'll continue in the next video for question number B. 1C. We'll continue in the video for question 1C. This is question 1C, where we have to show those 3 results. So the showing there, I think I can even give this as a task. Show that. So you can try to show this and send me your solutions, but I'll be able to create a certain video for this alone. So try to do this as a task and send me the solution. 0964 736805. Send me this task and send me the solution. So we have to show that the left hand side is indeed the right hand side. So just simplify this based on the combinations what you know. So combination of that plus combination of that, is it true that it is going to give you that? That's what you are going to use there. So combination of that plus combination of that, is it true that it is going to give you that expression? So obviously you can calculate the left hand side and you calculate the right hand side. If the answers are the same, it means you've shown. As simple as that. That's what you do. The same applies with the second part and the third part. The third part there, you are just showing the combinations of that and that if the thing are the same. So send that solution to 0964736805. I'll be expecting solutions. Thank you very much, and see you in the next lesson.